or is on measuring angles. Okay, so an angle is formed by two rays with the same endpoint. So they meet up at what's called the vertex. The rays are called the sides of the angle, and the endpoint is the vertex. So in this picture, we have a side, and this point B would be a vertex. Okay, so the angle on the right can be named in three different ways. So we always use the vertex angle to name an angle. So like I could call this angle B, unless there's things like in number 1. Do you guys see why I couldn't name an angle Q in number 1? Yeah, because there's more than one angle that would have that vertex, right? So sometimes we're going to use letters. So we could say angle B, or we could say FBA, or we could say ABF, like that. Does that make sense? Notice how the vertex angle is in the middle. Okay, so when I say FBA, it means I start at F, I go through B, and then I go up to A. That's that angle. Does that make sense? All right, so it says name the angles in the figure. So I could say I have angle PQS, I have angle SQR, and the big angle would be angle PQR. Okay? But these aren't the only ways of naming these angles. So if I have PQS, the small angle, what's another way of naming the small angle? A what? Angle, you can't do angle Q because there's more than one. So we got to be a little bit more specific with that. Yeah?
SQP?
Yeah, we could do SQP. We could put it in reverse as well. Does that make sense? So all of these have other. So this could be angle RQS. And this one could be angle RQP. Okay, so we just have to be careful. If there is more than one angle, we don't just use the vertex angle. But that's definitely the easiest way of writing if there's a single angle. All right, so name the angles in the figure. So we could have angle EAB. So that would be this angle right here, the right angle. What else do we have? Angle CAB, cab, or BAC. Doesn't matter. It's the same one. An angle DAC. Do we have any other angles? So I know you can name them in different ways. Like DAC, I could do CAD. Are there any other angles? Yeah, Cam, what do you think?
Oh, sorry. I was going to say EAB.
Yeah, Joseph?
DAE.
DAE or EAD. Yep, exactly. So DAE works. Okay, that's what we call a straight angle. Which seems kind of counterintuitive, right? Wait, an angle that's straight, isn't that just a line? But angles can be 180 degrees as well. All right, so the measure of an angle is written like the measure of angle A, but if I refer to just the angle, the object itself, I write angle A. So that's kind of similar to what I was talking about the other day with congruent segments. So if I talk about congruent angles, we typically use these little marks. Do you guys see how there's like a little swoop there? Like maybe I have one swoop and one swoop. That means those angles are the same. You guys can kind of see it on your page. It's kind of tiny. And I also could do like, sometimes you'll see two swoops. That means it's the same. And then that one gets a little out of control though with angles. So sometimes like you wouldn't want to do 1, 2, 3, 4, 1, 2, 3, 4, would you? That seems a little excessive. So what we do then is we start doing like one swoop with like a little line. Those would be the same. Okay, so we're going to be marking angles in that way throughout the class. So congruent angles are angles that have the same measure. So we could say their measures are equal. So we could say, oops, and the objects are congruent. So I could say like angle A is congruent to angle B, but I could also say the measure of angle A is equal to the measure of angle B. The objects itself we read as they're congruent, and we say the numbers, like the measure of an angle, is equal to the other number measure of the angle. So it's a slight difference, and we'll talk about that throughout geometry. So we're also going to use quite a few markings, like I said, to show that angles and segments are congruent. So here's an example of two triangles that have 3 pairs of angles congruent and 3 pairs of segments congruent. So it says write congruence and equality statements for all the triangles on the right. So if I talk about congruence, I want to talk about the objects. So let's start with the segments. So congruent segments. So I could have that segment PR is congruent to segment what? So look at P going to R. What's it match up with over here? L going to K. So I went from the red to the blue. I'm also going to go from the red to blue. You guys don't have the colors on yours, but. So it's L to K. So that's one of them. So I could also say P and then C, that's going to be the same. That's going to be congruent to L to J. And the last one is Q to R is congruent to, so I went green to blue, so I went green to blue. So J to K. Okay, so if you don't have the colors on yours, so yours I think were printed in gray, right? Then look for those markings. So one of them had 3 swoops, one had 2 swoops, one had 1 swoop. Okay, so equal segment measurements, we would just say that PR is equal to LK, PC is equal to LJ, and QR is equal to JK. So if you remember yesterday, what I was saying is segments are congruent. When I would talk about the segments, the objects, I put the line over them. But if I'm talking about their measurement or the distance, that's a number associated with it. I don't do the line over them. So this is a number equals a number. Yeah, Rhett, do you have a question?
Where's the C?
Oh, is it C? Q, sorry, Q, thank you. I did it right on the other one, but not right on that one. Okay, so then congruent angles. So we can probably just use a single letter this time, right? So we're going to say angle P is congruent to angle, which one does it match up with? You guys can see it. Do you see the markings? So this one has 3 swoops, this one had 2 swoops, this one has 1 swoop. So look for the one that matches up. So we have L, exactly. And then we have angle R is congruent to angle K, and angle Q is congruent to angle J. And then equal angle measurements, we would just say the measure of angle P is equal to the measure of angle L. The measure of angle R is equal to the measure of angle K. And the measure of angle Q is equal to the measure of angle J. So we're picky. We're very, very precise in geometry. All right, so let's try some problems. So first, before we do the problems, I guess we needed to talk about certain types of angles. Now, I'm sure that you guys talked about this probably in elementary school. Have you guys all talked about acute, obtuse? Yeah. So give me a definition for an acute angle. Yeah, what do you think? Oh, I was pointing at him. Go ahead, Colin. An angle that's less than 90 degrees. Okay, so it's between like 0 and 90 degrees, right? So it's, we'll say less than 90 degrees. I would say a cute little angle. Have you heard that before? Okay, right angle. Yeah?
90 degrees exactly.
At 90 degrees exactly. Exactly. And we draw a little square, like a little box in the corner to indicate 90 degrees. Obtuse angle. Between 90 and 180. Not including those numbers, right? So that would be an angle like this. And then a straight angle, 180 degrees, exactly. So it's straight like this. That would be a straight angle. So it says, when using a protractor, one must first decide if an angle is acute or obtuse, because a protractor has both sets of numbers on it. So do you guys see this example of a protractor here? Notice on the top rows, we have numbers like 120, but then we also have 60. So you need to decide, am I using the obtuse number, 120, or am I using the 60? Okay, so I'm going to pass out some protractors for you guys, and I'm going to have you measure each of these angles. Now, the reason I have you guys do this is because when I taught at IU, I taught a class that was like for elementary ed majors in geometry, and I had several students that were 19, 20, 21 years old and didn't know how to use a protractor. So we're going to figure this out in geometry on how to do the protractor. So let's figure this out. Okay, so as you guys were measuring, I think you guys were noticing that you couldn't really see it. So if you extend one of these lines, that helps. And then when you put your protractor on here, you want the hole to go right on that vertex, and you want to make sure that this says 180 degrees right there, or 0. It's going to match up there. So when we put it on there, and we measure, we saw we were between 50 and 60, and it looked like it was a little bit more than 55, so I agree. I think it's 57, so Colin said 57. We'll go with that. Okay, does that make sense? All right, so how about the next one? So you have to move your protractor so that the line lines up with one of them. So I'm putting my protractor on like this, so the hole's right there. It didn't matter which way, as long as I had it lined up with one of those lines. And mine actually has a very handy like crosshairs type thing. So line up that crosshair with the line. So what two numbers am I between?
30 and 40.
Yeah, it looks like I'm between 30 and 40. Is it closer to 30 or closer to 40?
Closer to 40.
Closer to 40, so it's going to be bigger than 35, right?
So I think it's like 39.
Yeah, I think it's like maybe like 38. I'm going to say 38. Maybe 36.
Maybe it's 39.
Yeah, so often you're going to be off just a little bit, which is fine. All right, so is this next one acute or obtuse? Obtuse. So now when I put it on, what two numbers am I between? So I'm going to extend my line. 120, 130, is that what you're saying?
Mm-hmm.
What do you guys think? 120, 130?
125.
So he's saying 125, somewhere around there. All right, let's look. It's hard to extend my line with this big marker here. All right, yeah, I think it's between 120, 130. I agree. It looks pretty close to 125. Do you guys want to go with 125? I think it is 125.
Got him.
All right, good. So that's how we measure. Can we all do that? You got that. All right. So the next thing. So the ruler postulate. So it says the measure of the angle is the absolute value of the difference of the real numbers paired with the sides of the angle. Now, when I did this, when I was finding the measure of these angles, I told you that I put my protractor like this. Can you guys see on my screen? I put it like this. Doesn't that make it much easier? So what they're saying in the ruler postulate is they're like, well, what if we put it like this? And this one was at 120, or not 120, let's say 60. And this one was at 98. Isn't that kind of annoying doing it that way? Does it work though? Could I do like 98 minus 60 and get it? Yeah, totally. So it works, it's just kind of annoying. So that's what this ruler postulate is saying. It's the absolute value of the difference of the real numbers paired with the sides of the angle. All right, easy enough. All right, an interior point is a point inside of the angle, an exterior point is a point on the outside of the angle. So for the angle addition postulate, we need a point that's inside. So this is an interior point here. And what it says, so let's think about it, guys. Let me draw some numbers up here. What if this is 60 and this is 10? What do we know about this whole angle? It's 70. Isn't this just like the segment addition postulate? Do you guys remember the segment addition? It was like, oh, if this is 2 and this is 5, the whole thing is 7, right? It's easy enough. So the angle addition postulate says that. So when I write this out, I'm going to say the measure of angle AOB added to the measure of angle BOC, so the medium one plus the small one, equals the measure of angle AOC, the biggest angle. Does that make sense? Easy enough. So let's use this in some problems. So it says use the angle addition postulate. So it says what if the measure of FCD, so this angle right here, is x plus 41, and the measure of BCF is x plus 78. Find the measure of BCD, or no, it says measure of BCD is 95. So this whole thing here, so going all the way around is 95. So find x. So can we come up with an equation that's going to allow us to find x? Yeah, Keegan, what do you think?
I just said x plus 78 plus x plus 41 equals 95.
That's exactly right, and that's going to allow us to solve for x. So we get 2x plus 119 equals 95. So we subtract over, so 2x equals 95 minus 115, or 119. So what is that? So couldn't I do like 100 minus, I could kind of carry, it might help. 100 minus 19, add the 5. So what do we get when we subtract these? Negative 24. So then 2x, so x is equal to negative 12. And a lot of times with geometry, like sometimes we can't have negative numbers, but in this case it's okay. So if I plug in negative 12, I don't get any negative angles, right? So we're good. So that works. All right, so the next one, so VUT. So VUT is this big angle here, which looks almost like 180 degrees, but it's not. It's 175. And then VUJ is 17x minus 3. And JUT is 17x plus 8. So our equation is that we add the 17x minus 3 to the 17x plus 8, and we get a total of 175. So we're going to add the 17s together, so we get 34. We subtract the 5 over and get 170. So 34x equals 170. So do you guys know what it is? It's 5. All right, so we got x. So remember, sometimes these are two-part questions, so your homework might not say find x, it might say find the measure of angle VUT, right? So or VUJ or something like that. So you'd have to go back and plug in. Okay, does this make sense? Feeling good about these? All right, so you guys try the next one. So try C and then plot the points for number 2. So one thing at a time. All right, so what are we getting? So you had ABC was 17x plus 8. That was the big angle, right? ABK was 42, and KBC was 12x minus 4. So did you guys have 17x plus 8 equals 42 plus 12x minus 4? All right, so when you solve this out, so it looks like we get 5x when you subtract over, 38 minus 8, so 30. So did you guys get x equals 6? And now this is one of those two-part questions that says the measure of ABC is what we're supposed to find. So we go back and we're like, well, ABC was 17x minus or plus 8, so I'm going to do 17 times 6 plus 8. So what did you guys get for that? 110? Everybody agree? All right, good. All right, so number 2, so did you start plotting the points? So you're plotting negative 3 comma negative 1. Now, as you do this, I would label. Oops, I put a positive 1. So negative 3 comma negative 1. So I'd put A. And then I have negative 1 comma 1, B. And then I have 2 comma 4, C. And I have 2 comma 1 is D. And 2 comma negative 2 is E. So it says use a protractor to measure and classify the following as acute, right, obtuse, or straight. So we don't have to necessarily use this protractor. Let's look at it. So DBE. So be careful. What's the vertex of that angle when I say DBE? B. So it means I'm starting at D, I'm going over to B, and then I'm drawing an E. So you got to do it in that order. Did you guys all see the angle that I drew? So is this acute, obtuse, straight, or right? It's obtuse, right? Okay, but the next one, EBC, what do we think here? So EBC. It looks like a right angle, doesn't it? Do you guys think a right angle? So you can measure with your protractor. Now think back to Algebra 1. How can I tell if lines are perpendicular using their slope? If they're going to be negative and positive, and they're going to be reciprocals of each other. Let's count the slope. So if I count the slope of this line, guys, look up here. So it's going to go down 1, 2, 3 over 1, 2, 3. The slope of this first line of BE is negative 1. What about this other line? Up 1, 2, 3 over 1, 2, 3. That slope is 1. So are those opposite reciprocals of each other? Yeah, they are. So the slope of this first line was negative 1, and the slope of this one was 1. So they're opposite reciprocals of each other. So yes, it would have to be a right angle. All right, how about ABC? What do we think for ABC? Straight. And then the last one, ABD, obtuse. Yep. All right, so how about a clock? So it says find the angle measures for the hands of a clock.
I think it's about
All right. ABD, what did I do?
It's supposed to be cute.
Oh, did I write something down? ABD? I don't know what you're saying. DBE? DB, oh yeah, why did I write obtuse? It's a cute, yeah, thank you. Why did you tell me earlier? You let me get all the way to D? You were right. All right, so number 3. So find the angle measures for the hands of a clock. So 8 o'clock. So we're going to draw this clock out. So 8 o'clock, the minute hand goes here. The hour hand, let's think about it. We would have our 4 sections of the clock. And in between, we're going to have 2 measurements, right? Whoops, I got to draw that a little bit better. So we'd have 6 o'clock, 7 o'clock, 8 o'clock. So if I was at 8 o'clock, my minute hand goes straight up, my hour hand goes to 8. Who thinks I know? And tell me your thought process. So crucial. Okay, so I'm not asking if it's acute, right, straight, or obtuse this time. I want you to actually find the number associated with it. So the angle measure for the hands of the clock. So when I talk about the angle measure, I'm talking about from here to here. So these 2 markings are going to have an angle between them. I don't know. How many dashes, how many degrees have to be between each one? 30, right? So between the 9 and the 8, there's 30 degrees right there, right? What about between the 9 and the 12? There's 90 degrees. So how many degrees do I have to have? Yeah, 120. That's it. That's our answer. 120 degrees at 8 o'clock. How about 2:30? Now what happens with a clock as the time's going? So at 2:30, our minute hand's down here. But as our 2, so when I talk about my, let me do with the dotted lines. When I talk about my 1 and my 2 o'clock, is it right here at 2 o'clock? Ah, yeah, you got to think about how clocks work, right? So let's look up at the clock right now. So it's a little bit past 1, right? It's 1:06 according to our clock right now. And see how the minute hand isn't, or the hour hand isn't on 1 anymore? It started to move a little bit. It's a little bit past it. Okay, does this make sense? So we're moving it between the 2 and the 3. So it's here and here. So now how many degrees separate between the 2:30 hour hand and the 3 o'clock? Half of the original 30, so 15, right? Good. And then we still have our 90 degrees here, so this ends up being 105. Perfect. Okay, how about 7:15? Oh my gosh. So let's draw our clock. So we're like, okay, let's draw these little grids in. So we have our 7 and our 8. 7:15 isn't going to be directly in half. It's going to be half of half, right? So half would be 15 degrees. Or half would be, yeah, 15 degrees. Half of that is going to be how much? 7.5. So just in here is 7.5 degrees. How about the 7:15? Well, that means that the other one is here at 15, right? So we have 90. We then have this much, which was our 30. And then we have another 7.5. So we're doing 90 plus 30 plus 7.5. So what do we get? That's it. That's how many degrees are between at 7:15. Tricky, isn't it? Oh, those darn clocks. This is why you guys all like digital clocks these days. It's too complicated, isn't it, with those clocks? All right, so I think that's the end of that section. So